Hey everybody, I wanted to spend a little bit of time going over question 16.49 in Brown-Lemay-Burston. And in this question, in essence, we're asked to write equilibrium reactions for acid reactants, and then we're going to write a Ka for it. But in the end, I think that writing the reaction is the more important part of this. I'll do both parts, but I wanted to do this. And then it says show the H plus and then show it with the hydronium ion. So we'll do both ways as it's asking, and we will and then we'll write the Ka for this. But keep in mind that whenever we have an acid reaction, the form of the acid reaction, as long as you're going to be writing it with the hydronium ion, is always going to be the same. We shouldn't change that reaction, and that's the way that I encourage you to write it. So you're going to have the acid, which is Ha, plus H2O, is going to react to form H3O plus, that's the hydronium ion, plus whatever the conjugate base of the acid is. And so that's the general form of the reaction, okay? And this will also work if we were going to do it with the hydrogen ion. But again, so that general form is going to be Ha is in equilibrium with H plus A minus, okay? But this is the form that is the most useful, okay, and maybe the most chemically accurate. So that's the one we're going to stick with if you have me as a teacher, okay? So let's do A, okay? So the formula or the reaction that shows hydronium ion, that's going to be, bromic acid. So it's going to be HBrO2 plus H2O is in equilibrium with H3O plus BrO2 minus. Okay, if you're going to write it with just hydrogen ion, it'll be HBrO2 is in equilibrium with H plus BrO2 minus. And when we do this, you'll see when we write the equilibrium expression, Ka, if we use this first one, it's going to be products over the reactant, so it's the concentration of H3O. Let me make sure my A is good. H3O plus the concentration of BrO2 minus, all over the concentration of HBrO2. If you're going to use the second equation, that's going to be Ka equals the concentration of H plus over the times the concentration of BrO2 minus, all over the concentration of HBrO2. So I think the whole teaching point of this is to say that these two things are equivalent, with the exception of where we're getting our acid from. Okay, in this one we're getting it from the more chemically appropriate hydronium ion. Here we're getting it from the more kind of shorthand notation of the hydrogen ion. And so not that either one is more correct than another, and it's going to give you the same answer, but I believe in this one. It's not that I believe in that one more. It's just that's to me the one that is more chemically accurate. Okay, so if we're going to do part B, okay, so part B for this was this compound, COOH plus H2O is in equilibrium with, not reacts to form, H3O plus, and the ionizable H is this one here. For organic compounds, the ionizable H is at the end. Okay, and so that's going to then be plus C2H5COO minus. And the so this is for part B. And then the other way, showing hydrogen ion as the product, is going to be this guy is in equilibrium with H plus C2H5COO minus. And then if we're going to write the equilibrium expression, it's going to be Ka equals concentration of H3O plus times the concentration of C2H5COO minus, the propionate ion, all over C2H5COOH. Remember, and I probably should have said this earlier, but remember that water is a liquid and doesn't play a role in the equilibrium. Pure liquids don't, only things that are in solution and gases. And then the other Ka is going to be the same thing, except instead of H3O plus, we're going to have H plus, and then C2H5COO minus over concentration of C2H5COOH. Okay. So there it is, a little practice for writing reactions and a little practice writing equilibrium expressions. Hope this helped. Have a great day.